Today in Learning Lua, we're going to examine math operations as well as the math library. The storage of numbers internally is done as either integer or doubles, or if you're using a version prior to 5.3, everything is stored as a double. I would also like to point out that we have a wonderful function built into Lua called toNumber that'll automatically convert strings into numbers. This is very useful if you need to do a comparison operation between numbers and variables, and you're not sure if the variable has stored the numeric value as a number or as a string. The basic operators available to us inside of Lua, like most programming languages, include exponential, multiplication, division, modulus or modulo, addition, and subtraction or unary. The order of precedence inside of Lua for doing calculations, as with most programming languages, is the highest order is exponential, followed by doing a not length check or unary. Unary does stand for converting a number into a negative number. Multiplication, division, and modulus are all at the same level, and then plus or subtraction. Now here's an example of order of precedence. In this particular example, I've got 5 times 4 plus 2. Actually, I've got 2 plus 5 times 4. But due to order of precedence, we receive the answer of 22. We utilize parentheses. Always, 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 when you're doing mathematic operations, if precedence matters, you need to use parentheses to make sure that your calculation is done correctly. Overuse of parentheses is not a bad thing. It's make sure that you get the correct calculation from what you're trying to compute. Modulus or modulo, depending on how you want to pronounce it, computes the remainder of a division calculation. So in this case, I'm taking 5 and receiving the modulus of 4, which gives me a remainder of 1 for that calculation. Modulus is frequently used in game calculations or moving objects around on the screen. Can be a very useful tool in what you're working on. Now we have a wonderful additional tool set available to us, and that involves using the built-in libraries that Lua has. Now Lua has multiple built-in libraries: math, string, table, input and output, operating system, and debug. We're going to focus on the math library today. I'll cover the rest of the libraries and what they are capable of doing in a later tutorial. The math library allows us to quickly and easily do advanced computations that might be time-consuming to do the formula. They've already been pre-built for us, and so we're able to take advantage of that. I'm going to look specifically at 2 that are the most commonly used inside of application development, and that would be pi and random. Random, of course, is the most used for game development. Pi is used for any time we need to do calculations that require pi. Using the math library and the extension .pi, I'm able to quickly get the value of pi, and there we can use it for multiple calculations. Of great interest to those who are doing game development is the random function. With the random function, we are able to generate a random number between a set value. If you don't provide a value, it will return a number between 0 and 1. The math.random command is of great use for game developers being able to randomly determine something. If you don't provide any parameters to the math.random function call, you will automatically generate a number between 0 and 1. You can specify, let's say I wanted to generate a number between 1 and 10. You can randomly generate that. When using the random number generator, you do need to be aware that this is a pseudo-random generator. If you do not reseed the random number generator, the sequence of random numbers that you receive each time will be exactly the same. Now that does have a useful value in certain replayability of games. If you want certain random sequences to come up every time, then don't reseed it. Reseed the random number generator so that each time that it is generating a random sequence of numbers, that's easily done with the reseed. So that's just simply random seed and then you need to give it some type of parameter to base that random number off of. We haven't talked about it yet, but you can use the operating system library to get the current time. By using the math.randomseed, it will generate a new unique number every time the application is run instead of the same sequence of numbers. Lua also includes a number of trig functions available in the math library, so if you need to compute sine, cosine, tangent, whatever, you can easily call those and use them to compute those trigonomic functions. We have a lot more tutorials and lessons forthcoming. If you'd like to follow what's happening, you can follow us on Twitter at Dr. Brian Burton, or Facebook at Burton's Media Group, or follow us on our website, burtonsmediagroup.com. If you'd like notification through YouTube, hit the like or subscribe button.